Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting Law of Logic.
First, let me introduce our group members, which is myself, Nur Aina Shahira. My metric number is 2023 at 44012.
Hi everyone, my name is Siti Nuradia and my metric number is 2023605148.
My name is Farsha Kisanahani binti Muhammad Afendi. My metric number is 2023657892.
Hi, my name is Nurul Amarina and my matrix number is 2023684336.
First, let's we go to introduction. The law of logic refers to fundamental principles that govern reasoning and argumentation. These laws are the foundation of logical thinking and ensure consistency in thought processes. Some of the most well-known laws include the law of identity. It is something is what it is. The law of non-contradiction is something cannot be both true and false at the same time. And the law of the excluded middle is either something is true or its negation is true. These principles are essential in various fields, including philosophy, mathematics, and computer science, as they help establish valid reasoning and clear communication. First, let we know about law of logic. First law is double negation. It's like not in bracket not P, close the bracket, equal to P. Second, De Morgan's law. First, we know as not in bracket P or Q, close the bracket, equal to not P and not Q. And it can be not in bracket P and Q, close the bracket, equal to not P or not Q. Third, we know as commutative laws. First, we know as P or Q equal to Q or P. Next, we know as P and Q equal to Q and P.
Next, we will talk about associative laws. These laws explain that we can rearrange logical statements if the symbol is the same. For example, P or bracket Q or R is equivalent to bracket P or Q or R. Similarly, P and bracket Q and R is equivalent to bracket P and Q and R. Next, distributive law. This one is like expanded bracket in algebra and only happen when the statement with different symbol. For example, P or bracket Q and R expand into bracket P or Q and bracket P or R. Similarly, P and bracket Q or R expand into bracket P and Q or bracket P and R. Moreover, we have idempotent law. This one is very straightforward and simple. It's about repetitions. It states that P or P will always give you P, likewise P and P will always give you P. In other words, repeating the same terms doesn't change the outcomes.
More about Law of Logic. So for 6, we got identity law, which is P or C will be equal to P. P or T will be logically equivalent with P. 7, inverse law. P or not P is equal to T. P and not P is equal to C. 8, domination law. P or T logically equivalent with T. P and C logically equivalent with C.
Next, we have absorption law. For this law, we have two formulas, which is P or in bracket P and Q logically equivalent with P. This shows that when you take P or P combined with Q, it's equivalent to just P. Second formula is P and in bracket P or Q logically equivalent to P. Similarly, they say that if P is true alongside P or Q, it's still just P. Next, implication law. The formula here is P implies Q logically equivalent to not P or Q. This explains how an implication statement can be rewritten or not P or Q. It's useful when simplifying logically statement or proving argument. Next, let's move to contrapositive law. For the contrapositive, the rule is P implies Q logically equivalent to not Q implies not P. Then, by conditional law, the formula is P equivalent to Q equal to P implies Q and Q implies P. This means that P is equivalent to Q if P implies Q and Q also implies P. It's established a two-way relationship between P and Q.
Let's we go to example. Example 1, the question is simplify the statements below using law of logic. In bracket, P or Q close the bracket and not in bracket not P and Q close the bracket. First step we do in bracket P or Q close the bracket and in bracket not P or not Q close the bracket. We call as De Morgan's law. Next we do in bracket P or Q close the bracket and in bracket P or not Q close the bracket. We call as law of double negation. Next we do P or in bracket Q and not Q close the bracket. We call as distributive law. Next we do P or C. We call as inverse law. Next and last step we do as P and we call as identity law.
Okay, let's move to example 2. Simplify statement below using the laws of logic. The original statement is bracket R implies S and square bracket not S and bracket T or not S. The first step is to use the definitions of implications where R implies S can be rewritten as not R or S. So our statement becomes bracket not R or S and square bracket not S and bracket T or not S square bracket. Next, we use the commutative law to rearrange the parts inside the bracket. So, T or not S can be written as not S or T. Then the result is bracket not R or S and square bracket not S and bracket not S or T square bracket. Now we apply the absorption's law and the entire term simplifies to not S. So the statement becomes bracket not R or S and not S. Then we use the distributive law to expand it and we'll get bracket not S and not R or bracket not S and S. Next, for the part not S and S, we apply the inverse law. Therefore, not S and S is eliminated and replaced with C, which is contradictions. And it will leave bracket not S and not R or C. Then we use the identity law, so we can simplify it to not S and not R. Finally, we apply De Morgan's law to combine the negations into one and we need to change the symbol. So the final answer for this logical statement is not bracket S or R. This shows that the whole statement can be simplified to a simpler form using law of logic.
So I will explain about example 3. The question is prove the following expressions using rules of logic. We got the equation is bracket P equivalent Q or not P logically equivalent with not P or Q. So we are using law to express these rules of logic. First step is bracket not P or Q or not P using implication law. Next, not P or bracket not P or Q using associative law. Q or bracket not P or not P using commutative law. Q or not P using idempotent law. Last but not least, not P or Q using commutative law. Then we can express this following expression using rules of logic.
Example 4. By using the law of logic, simplify in bracket P implies Q close bracket and in bracket not Q and in bracket R or not Q close bracket. First, we use the implication law, which states that P implies Q is equivalent to not P or Q. Substituting this into the expression gives us in bracket not P or Q and in bracket not Q and in bracket R or not Q close bracket. Next, we simplify the inner part in bracket not Q and in bracket R or not Q close bracket using the absorption law. According to this law, not Q and in bracket R or not Q simplifies to not Q. Substituting this back the expression become in bracket not P or Q and not Q. Using the commutative law, we rearrange in bracket not P or Q into in bracket Q or not P close bracket for clarify. Next, we apply the distributive law to distribute not Q over in bracket Q or not P close bracket. The expression becomes in bracket not P and not Q close bracket or in bracket Q and not Q close bracket. Here, Q and not Q simplifies to a contradiction, leaving us with C or in bracket not Q and not P close bracket. Using the identity law, we know C or in bracket not P or not Q is equivalent to not P and not Q. Finally, we apply De Morgan's law to rewrite not P and not Q as not in bracket P or Q. Thus, the fully simplified expression is not in bracket P or Q close bracket. In conclusion, understanding and applying the law of logic is essential for mastering logical reasoning and problem solving. This law, including double negation, De Morgan's law, associative law, and others, form the foundation of mathematics and critical thinking. By learning and practicing this law through exercises, students can strengthen their ability to analyze and construct valid arguments.
This is our reference in this video.
That's all from us. Thank you for watching.